this much data that I have no idea about, and this is one value out of that set. So let's assume an even distribution of all the rest of the stuff. And so those numbers can be really off. Like, for example, if you've got a value that appears 3 times in a giant table, and Postgres doesn't happen to run into a sample to analyze, and it's probably not, it's a rare value. Postgres is going to look at it and say, well, this looks like it's part of the 5% of the data that I hadn't seen. It's not stored in my buckets of frequent values and stuff like that. So it may assume it's like an even percentage of that based on the range that it's got, but it could easily be off by a significant multiple in the case where it has no idea what's going on. So the thing that's nice about setting the bigger values for the statistics target is the buckets, as far as the ranges for these things, start getting smaller, so the amount of really weird data that it has to assign for, I don't know, it's somewhere in this range starts dropping. But it's, getting a hard number on that, it really is kind of data dependent. What you'll normally discover is that the numbers are either they're in 3 categories. They're either really surprisingly close apart. So if you look at it and go, wow, I knew exactly how many rows are there. That's only what happens when you've got so much analyzed statistics data that it literally has accounted, there are exactly this many rows that match x equals 3, and it spits it right back out. Then this case where it just gives you a way out-of-line number, like factor of 100 or more off or something like that. The cases in the middle, factor of 2 to factor of 10, those are where it starts getting hard to do, and it may not be possible to solve that problem completely with statistics, but increasing statistics can make it less likely that you'll run into the nastier of the edge cases.
Is there a way to make it change how we determine the sample?
No, Analyze does its thing. The only real input on the Analyze process is this target for how much data it's going to store in its in earlier versions of Postgres, the default statistics target was 10, which is pretty ridiculous as far as how little data it collects on a newer server. Again, it made sense a long, long time ago. Starting at 8.4, it's moved up to 100. 100 is actually a pretty good value for a lot of databases. If you're out of the box and your number's at 100, you're probably going to be fine. If you've got a 100 gigabyte database, you're probably not going to be fine at 100 on everything anymore. But I mean, you only have a few gigabytes in the database, you're just getting started. I would not be concerned with the statistics target is something you got to do crazy optimizing right out of the box. The normal useful range for it is 100 to 1,000-ish. I think in 8.4 you can only set it to, or in 8.3 you can only set it to 1,000, and then it bumped to 10,000 in 8.4. And there is an upper limit on it I'm concerned about. I say 100 to 1,000 is the normal useful range because what happens if you start setting it to multiple thousands is this query overhead time starts getting a little bit ugly. The query overhead time, there are components to it that are actually proportional to the target squared, so that number grows really big when you get to some types of large data sets. It doesn't impact most things that people do, but if you start pushing your luck by trying to set this number into the 10,000 range, you're probably going to run into it. So I run a lot of servers with 200, 500, something like that. I start getting nervous if we go in and this needs to be 1,000 or more. As such, if it really does need to be 1,000 or more, that's definitely where you're going to start thinking about, well, let's make this a targeted thing. Let's make it 5,000 on this column. Because you can't set it that high database wide, but it is possible you may need to set it to a higher value of 1,000 for a specific column. It's just got a really weird distribution of the data or some other dynamic stuff. So this example here, a lot of people think that that's going to be a complicated thing to do. It's that simple. You just alter the table and say, set the statistics, that number, and you're done. And from then on, it will just automatically go in and collect that many more statistics when it runs in. it will give you timestamps for both when the last time Analyze was run manually and the last time that Analyze was run by these things only appeared in Postgres 8.3 as part of the fact is in why 8.3 is a better release for a lot of performance reasons. That automatic is extracted from a lot better version. You can look at the statistics data. It's not complete black magic. It's only mostly black magic. You can look at these MCVs, these most common values. You can look at these histograms, and if you know your data and you look at the statistics, it should make sense to you. It may be a little more math than you really want to get wrapped up in, but it's not like this is magic data and it's going to be optimized and you can't do anything with it. I've had clients of mine who are surprised when I dump the data out of PG stats for the thing that the query is wrong on. They'll look at it and they're expecting that this is going to be data that they just can't do anything with. And they look at it and go, oh wait, I see what the problem is. It's missing this entire type of data that's in the database. Oh, why doesn't it see that? Oh, okay, it needs more statistics to figure that out. Or it hasn't been analyzed recently enough. Last time it was analyzed was before that type of data appeared. So, it's not the first thing I would recommend, but if you're getting to the point where you're saying, hey, my estimates are off by so much that I think maybe I've got a statistics problem, I would suggest you do not be afraid to go look at PG stats. It's kind of a pain to navigate and get the information out of, just as far as fitting it on the screen is annoying. But the data itself is not really all that complicated. I will normally dump it to a text file and then load the text file in with an editor to be able to navigate the whole thing. It is worth your trouble, especially if you really want to look like a super Postgres guru. If you get good at using PG stat stuff and people ask you questions about why does this query run, and you answer them with things like, well, this query is slow because the selectivity is poor on this most common value feature, and therefore it's falling back to the equal histogram thing. People will assume you really know. So it's good for job security too, if you have this sort of information. Or even better if you're a consultant. So statistic stuff is important, and it is not as scary as it seems. The documentation is somewhat cryptic, but if you go look at PG stats, you may discover it's easier than you expected to figure it out, and I do recommend that people take a look at that stuff. Vacuum. Vacuum happens after a couple of things. When you insert a row into Postgres, that's great. That goes in there, and that doesn't cause any future problems. When you delete a row, what that does under the hood is it says this row is no longer visible as of this particular transaction ID. And because it's possible that there may be queries running that still need to see the old version of that row, it can't just overwrite it immediately. This is central to the MVCC concept that I was commenting you'll hear more than you ever want to know about if you show up at Bruce's talk. So when you delete something, it just says this is no longer visible after this point in time. You can't actually remove it from disk until later. The same thing happens with update. Update is actually the most intensive single row thing that you could do, because update both has to go to the original row and say you're not visible as of this date, as of this transition, and it has to go create a new row somewhere else with the new version of the data, and then both of those rows are still visible in parallel. And what vacuum does is it goes and it finds these things that are left behind by updates and deletes. They're called dead rows within the server, and it cleans them up visually. So how does it decide what it's going to do? Well, there's a background process that is available in earlier versions, but it doesn't really get automatic scratch until Postgres 8.3. Auto vacuum will update the database statistics we were talking about, and it will also clean up after these things. It works off of a threshold concept. The idea is it tracks how many changes have been made to the database since it last did auto vacuum or vacuum, and then when that number is above a threshold, it executes something. The computation of it is a little bit weird for small tables, but the easy way to remember it is, if it's a non-trivial table, it will run auto